To find this derivative, it might be helpful to rewrite this function in exponential form. That this is the same as 16 take away cosecant of x to the 1/2 power. You know, there is an outside. There is also the inside, the outside, the inside. So we've got to use that chain rule. Okay. Now, we're going to have to use the power rule too. We'll take that power of 1/2, put it out front. Then we leave what's inside and subtract 1 from the power. Well, 1/2 take away 1, that's 1/2 take away 2/2. And 1/2 take away 2/2, well, that's just negative 1/2. That's the outside. But what about the inside? Now on the inside we have 16, and the derivative of 16 is just 0. We don't need to write that. But the derivative of cosecant is a negative cosecant cotangent. But there's also a negative right here. So we're going to have a double negative. That's going to turn it positive. And the derivative of that cosecant is cosecant cotangent. Okay, well, let's see what we can do with this. We do have that 1/2 out front, meaning 1 could stay up top. We don't normally write that. In the bottom, we would have a 2. We can also move this base to the denominator to make that power positive. Call this 16 minus cosecant of x to the positive 1/2. What would remain up top? The cosecant cotangent. 1 times cosecant cotangent is just cosecant cotangent. Now this is just fine. If you want, you can toss this binomial back into a square root. We've got cosecant x cotangent x divided by 2 square roots of 16 take away cosecant x. That's your derivative.